Hey everybody, this is Mr. Walsh coming at you with question from Brown LeMay Burston. Let me get rid of the calculator here. And the question is 14.4 right out of Brown LeMay Burston, and we're going to talk a little bit about some general rate loss stuff. Okay, so in this problem, we're given a graph, and we want to figure out some of the characteristics of the graph based on its shape and what's going on. Okay, and in this, it's given theoretical compounds K and L, and those react to form M. And so what we're doing is we are monitoring the production of M over some amount of time, and it looks to be about 30 minutes. Okay, so it says, is the reaction occurring at a constant rate from t equals 0 to t equals 15? Okay, and that's this line here. And so for A, the simple question, or the simple answer is yes. Okay, and the reason why is, keep in mind that the rate is the change in concentration. In this case, it's the change in concentration of M over the change in time, which, if we look at this and remember our algebra, rise over run, that slope, the slope of this is a line, and so it is always constant. A straight line, constant slope. So that means that, yes, for part A, when this is going from 0 to 15, the slope is constant, and so the rate is constant. Now, for part B, it says, is the reaction completed at 15 minutes? Now, this is a tricky question, and it depends on how you've been taught. So I have to take the way that I teach this, okay? And so complete means, is the reaction gone to completion as much as it's going to, okay? And my answer is yes, okay? And the reason why I say that it's yes is because here the slope is equal to 0, which means that the rate is 0, and that means that the reaction is not, there's no new products being made or no new reactants being made, okay? And so if that's the way you were taught, then that's great. The alternative is, some people say that complete means that all the reactants are used up. And that may not be the case in this case, and we can't tell from this graph. So that's the thing. But I think that primarily, because the slope is 0, we're going to say that that the reaction is complete. It's not going to go anywhere. Okay. So now for C, it says, suppose the reaction is plotted. Here we're started with 0.2 moles and 0.4 moles of L. So here at the beginning, you have 0.2 K and 0.4 L, okay? After 30 minutes, an additional 0.2 is added, okay? Which of the following correctly describes how the plot would look? Okay, and it gives us a whole bunch of things. So we have K plus L reacts to form M, okay? And so again, this is maybe the definition here, but so this just means that this reaction is done, okay? And so if we started with 0.2 and 0.4, that means here, and I have to assume that the stoichiometry is the stoichiometry, okay? That means at the end of the reaction, we're going to have 0.2 moles of this, okay? 0, and we're going to have 0.2 here. So if at 30 minutes we add another 0.2 moles, okay, 0.2 after 30 minutes, well, we still have 0.2, and it's still a 1-to-1 ratio. So this is now going to react. Now, the question then becomes, is it going to have the same slope? We know that this is going to react because there's some K and some L. Okay, but how quickly is it going to react? Okay, well, it's tricky here a little bit. Okay, it's going to react probably, if I had to guess, it's going to react with the same speed, because all that this is contingent on is how much K there is, okay? And then once we get down to 0, it's done. So this is going to probably, if I had to guess, go up to and react for 15 more minutes at the same slope and then level off again, because we'll then at that point, after another 15 minutes, we've used up all of this, and we've formed some M, more M. Okay, so once we had that, let's see what answer that is. M would increase with the same slope until 40 from the plot becomes horizontal, or, okay, so here are the questions. It's either going to remain the same constant value. Well, it's not going to do that because there's still some K, and now there's L. There's still some L left over, and then you add K. So that's not going to happen. Okay, and so it looks like it's choice 2 here. And now when we get into choice 3, it's decreasing. Well, it's not going to decrease because that would be a negative rate, which would imply that the reaction is going to happen backwards, okay? That means that negative rate means that whatever is being measured is disappearing and not appearing. So that's not going to be the case. So it looks like the correct answer is part 2. It's the only one that makes sense regardless of how we interpret this, whether we're talking about it going to completion or being in what we call equilibrium, okay? And so that this is going to go up with something like the same slope there, okay? It's definitely not going to stay even, and it's definitely not going to go down. So that goes over 14.4. I hope that clears some stuff up, and we'll talk to you later.